Okay, guys, welcome. Today we're going to talk about absolute value and a little bit about inequalities as well. Okay, so first we'll talk about absolute value. Now, when most students hear absolute value, they think correctly that whatever's on the inside, you're just going to make that number positive, right? But what absolute value really means is it's really talking about the idea of a distance on the number line, right? And of course, distance can't be negative, so that's where you're getting the idea that it's always positive, right? Or that's very small as 0, right? So if you want to take the absolute value of a number, all that you need to do is just make it positive if it's not already positive. So the absolute value of -6 is 6. The absolute value of 17.4 is already positive, so you just keep that as a 17.4. Okay, part C, we want the absolute value of 0, and that's just 0. Now in part D, we need to do a little bit of simplifying first. Right, now absolute value is another grouping symbol, right? So you can think of them as parentheses. So you want to deal with what's inside there first. So if I do a 4 minus 9, that gives me a -5. And of course, the absolute value of -5 is just 5. Right, and then last but not least, we got a fraction one here. We got 2 over 5 minus 6 over 5. So luckily the denominators here are the same, so we can just do 2 minus 6, which is a -4 over 5. So this is positive 4 over 5. Okay, so if you have something in absolute value, you essentially are working until you can just take the positive of either a negative or positive number. Okay, so let's do a couple more examples. So in part A, we have absolute value -3 plus absolute value -6. This is just going to become a 3 plus 6, so we get a 9. Okay, now in part B, we have to deal with each of the insides of the absolute value first. So this will become a -2. This will become a +2. But now absolute value of -2 is 2. Absolute value of 2 is 2. And if we subtract them, we get a 0. All right, in part C, we have the absolute value of 4 minus 7 divided by the absolute value of -6. So up top, we're going to get an absolute value of -3, and the bottom is just going to be 6. So then we get a 3 over 6, which is a 1/2. Okay, last but not least, part D, we get a 2 minus 8 over 3. So up top, we're going to get a -6. And -6 over 3, we can simplify to be -2. So this is just going to become +2. All right, so that's what we get for that one. Okay. So to sort of wrap this up together, how do you define absolute value? Well, if A is 0 or positive, you're just going to leave it alone. And if A is negative, you're going to take the negative of it, which would make it positive, right? So that's sort of how that works. Okay, so for any two real numbers, absolute value is always non-negative. That's one thing that we said. The absolute value of A is equal to the absolute value of -A, right? Because this would just become positive and both of these would just come out to be A, right? And then in number 3, the order inside the absolute value doesn't matter, right? So you have A minus B or B minus A. If you take the absolute values, those would give you the same thing. Okay, so at the beginning of this, I mentioned that absolute value is used to express distance, right? So if you have 2 points on the number line, which we're going to call A and B, you can find the distance between A and B, right? So if you have point A and a point B, and you want this distance, this is just found by taking the absolute value of A minus B, where you could also do B minus A, right? Since that distance should be the same regardless of where you start or finish. All right, so in this example, we have that A, B, and C on a number line have the coordinates -4, -1, and 3. So -4, -1, and 3. All right, let's see. Do I need to plug in my charger here? Yeah, give me 1 second. Let me plug in the charger here. Okay, so here's my cable. Let me just plug this in real quick and we'll... Okay, we're good. We're back. Okay, so, and of course, we're going to denote the coordinate 0 with an O. So here we have A, B, O, and C. Okay, we want to find the following distance. So if I want to find AB, I just need to take the absolute value of A, which is -4, minus B, which is -1. All right, so of course, we add a line, change the sign, and we get absolute value of -3, which is just 3. Now, of course, you could have just found this by counting, right? You could go 1, 2, 3, and you see that it's 3 units away. All right, but the idea is that once these numbers get big, it's much easier to think of it this way. All right, so that was part A. For part B, I want to find CB. So C is 3, B is a -1. So that's going to give me an absolute value of 4, which is just 4. All right, and then part C, we want OB. So we have a 0 minus -1. So we'll get absolute value of 1, which is just 1. Okay, so that's the idea there. Okay, so now for the rest of this video, we'll talk about inequalities. All right, so these are sort of the next concept that's related to the number line. Okay, so if you have two real numbers, you can compare the relationship on the number line by using these symbols, right? So you could use less than, you could use greater than, less than or equal to, or greater than or equal to, right? So those are the signs again right there. So of course, if something is further to the left, so we'll say this is A, we'll say this is B. If something is further to the left on a number line, then we say that it's less than something that's further to the right. So in this case, A would be less than B. Okay, so for example, let's put all these numbers on here. So A, we have 2 and we have 5, right? So of course, which one's further to the left? 2 is, so 2 is less than 5. For part B, we have -1 and 3. Of course, -1 is further to the left, so we'll have -1 less than 3. Okay, in part C, we have 6 and 4. Now this one, 6 is further to the right, so 6 is greater than 4. Right, and then of course D, we have 3 and 3, and of course those are just equal. And of course, if you wanted to, you could use less than or equal to, that's technically not wrong, or greater than or equal to, that's technically not wrong. But you usually want to be as specific as possible here. Okay, now to graph inequalities on a number line, you want to make use of proper shading, right? Now, of course, if you're going to include a particular point, if you're not going to include a particular point, in other words, you don't have the equal sign here, you would use an open circle. And this will make more sense once we do a couple of examples. If you include the point, meaning you do have the equal sign, you're going to use a closed circle. And then, of course, you shade the appropriate region. If you want greater than, you would shade to the right of the number. If you want less than or equal to, you'd shade to the left. Okay, so for example, let's look at x less than 3. So if I have 0 here, 3 is somewhere over here. Now, for this one, I have an open circle because I don't include the equal sign, right? So there's no equal sign here. So it's an open circle. So I have an open circle on 3. Now, if I want numbers that are less than 3, I want numbers that are down here. So I'm going to shade everything to the left of my 3 there with an open circle, right? For part B, so that was part A. For part B, let's get another number line on there. If 0 is here, -1 is here. Now this time, I do include the equal sign, so let's get a closed circle now. And if we're greater than or equal to -1, I want numbers that are bigger, so I want to shade this side. All right, so that's what we sort of mean there. Okay, so if we're given an arbitrary number line like this, we can still make comparisons between two numbers, even though the values here are sort of arbitrary, just by their position on the number line. All right, so for example, in part A, we want to fill in the appropriate inequality symbol. And since A is further to the right than B, A is bigger than B. Okay, for part B, we have C and A. A, again, is further to the right, so that's going to be greater than C, or C is less than A. All right. For part C, we have B and 0. 0 is further to the right, so 0 is greater than B, or B is less than 0. And then for part D, we have D and A. D is further to the right, so in this case, D is greater than A. Okay, so that's how we can use the number line to sort of compare two numbers. Okay, so let's take a look at a couple more examples. So for part A, we have x is greater than or equal to 2. So since we have the equal sign, we get a closed circle. And if I want numbers that are bigger than 2, I need to shade this side of the line. All right, for part B, we have 0 and 2 again. Only this time, since we don't have the equal sign, we have an open circle. And since I want numbers that are less than 2, I'm going to shade this side. All right, so those are just a couple more examples. All right. Now, of course, we can talk about compound inequalities, which just means that we have more than one inequality that we consider at the same time, right? So if you look at an example like this, we have -1 less than or equal to x, which is less than 2, right? So this implies that you have two things going on. This means that -1 is less than or equal to x, right? That's just this part here. And it also implies that x is less, than 2, right? And that's that part. Well, if x is bigger than or equal to -1, but less than 2, 2, we have an open circle since there's no equal. -1, we have a closed circle since there is the equal sign. And if I want it to be bigger than -1 but less than 2, that means I'm shading in between. Right? Of course, for example 7, same idea. We have -3 and -1. In this case, both open circles. And since it's bigger than -3 but less than -1, I again want in between here. All right, and then part B, we have -2 and +3. So both of these have the equal sign, so they're both going to get closed circles. And then, of course, we want to shade in between those 2 points. All right, so that's how we can sort of express these on a number line. Now, one more thing. Wait a minute. Let's see. Okay, so a couple more things here. Sorry. So if we're given a specific type of number that we want to plot here, we have to be a little bit more careful, because now it's not just shading. So now we want x to be between -5 and 4, but we need it to be a natural number also. So of course, again, if you have 0 somewhere in here, then 1, 2, 3, 4. Now remember, your natural numbers are your positive whole numbers. So the only numbers here are 1, 2, 3, and 4. Actually, sorry, not even 4, because this is strictly less than. Okay, so you have to be a little bit more careful here. Now for part B, we're still between -5 and +4, only now we can now use integers. So we have 1, 2, 3, 4, -1, -2, -3, -4. Right, so now in this case, we have all these numbers now. Right, and of course, don't include -5 or 4 because it's not equal. Now in part C, this is sort of like what we were doing, only now we're including the real numbers. So that's everything in between here. So that's where we shade. Right, because that's any number you can think of between those two numbers. Okay, now if you see this in your textbook, this set builder notation, this is fine. I'm not going to stress this too much in this class, but if you see it, this is what we mean by it. So set builder notation is just like another way that you can sort of classify sets here, right? So here we're going to let Q, for some reason, Q is the set of integers in this case. All right, usually we don't use Q, usually we use a different letter for that, but that's okay. This vertical bar here sort of means such that, and then this is sort of the specific part that we want, right? So this literally reads, A is the set of all X in Q, means the set of all integers, such that those integers are between -3 and +2, right? And that's sort of what this is all explaining here. Okay. All right, so let's just do a quick example of set builder notation, and then we'll talk about the last topic in this video, which is what's called interval notation. Okay, so if n is the set of natural numbers, we want to write the statement, the set of A of all natural numbers less than 10 in set builder notation, right? So we could say that A is the set of all natural numbers, so we'll say X in n, such that X is less than 10. That's the set of all natural numbers that are less than 10. Okay, what are these elements? Well, A, to be specific, is 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so these are saying the same thing. All right, these are really equal, but the top is maybe a little bit more convenient to write. Okay. Now, one final thing that I want to talk about here is what's called interval notation. Now, interval notation is sort of used to take the number line representation one step further, right? So if we're given a number line that looks something like this, where we're shading from A to B, and say maybe A, we have an open circle, and B, we have a closed circle, we can write that equivalently in this form here, right? So your first number is where you start shading. Your second number is where you stop shading. If you have an open circle, you would use parentheses, or if you just continue on forever and you go towards infinity or negative infinity, you would also use parentheses for that, right? Brackets would mean that you have a closed circle, right? So here you see that B has a bracket because it has a closed circle. Right? Where A has a parentheses because it's an open circle. right? Now, if you have multiple regions, you can use this, you can join them together with a union symbol, which is just like a fancy U symbol here. All right, so for example, if you wanted to say the numbers that are bigger than A but not including A, well, use a parentheses to not include it. You start shading at A, so that's your first number. You don't stop shading, so that just goes to infinity, and infinity also always gets a parenthesis. Okay, for the second one, we want to say all the numbers that are less than B and also including B. So we start at negative infinity, so again, another parentheses here, and we stop at B, but we include B, so that's where this bracket is coming from. All right, now in the third one, you want all the numbers up to and including C, and also all the numbers after D, right? So to say the first part, that's negative infinity to C, and since we're including C, we would use a bracket. And then we use that union symbol, that U, to also include the set from D to infinity. All right, and then last but not least, just as one more example, we could say the set from A to B where we include both. Since you're including both, you would use brackets, and then union that with C to infinity, and of course you're not including C, so you get parentheses there. All right, so that wraps up this video on absolute value and inequalities. I hope you enjoyed, and I will see you next time.